All right, guys, here we go with some 7-2 notes. You're going to love this first section because it's so darn easy. So we're talking about inverse coordinates, and it is as simple as doing this. I've got a coordinate of 4, comma, -7. I'm going to invert the x and y coordinates, make it -7, comma, 4. I know what you're thinking. There's got to be some sort of catch, but I promise you, no catch. That's all you have to do. So third set of coordinates, coincidentally, if we switch them, you still end up with 0, 0. Switch the last set of coordinates. All right, just one detail. Notice no signs were switched. So we're not switching any signs here. So you're literally just flipping the x and the y. Also, if you notice here, notation's sake, the exponent of -1 stands for an inverse. So if we start with a function f, if you want inverse function, you really need that notation. And you just got to remember to put a little -1 there with that guy. Same thing for if you were doing f of x, we would say f of -1 of x, but you do need it. Now, I'm going to bore you with the sec one for a reason. Whoa, don't need that. So 1.2, comma, -0.7. So if you want, while I'm filling these in, read that next line. See if you can figure out what I'm going to say there. All right, Brainiacs, what do you think? You got any ideas here? So a relation can be anything, any set of coordinates, any basically mathematical connection. But if we say function, this is way back, chapter 1 maybe, not even sure. The fact that we have a repeat in the domain, the x's 1.2 and 1.2, would make this guy not a function, but an inverse, relation instead. But I'm not going to ask you that, so really all you need to know is that I have to flip the coordinates, and that is probably literally the easiest thing we've done all year. All right, moving on. Please look away from Pretzel Man there, and let's figure out how to write inverse equations. Now, simple as this, if you remember what x and y in these problems actually stand for. So if you're doing something graphing-wise, well, hey, x stands for an x coordinate and y stands for a y coordinate. And you just got done flip-flopping the x and the y coordinates, or we did, in the previous set of problems. So to write an inverse equation, check it out. Flip the x and y, just like we did with the coordinates. So I'd like to tell you that's it, but sometimes in math, you just have to do what's standard. And standard for anything to do with functions or graphing means you typically want to have y by itself. So they're going to insist that once you do that easy part, that you go ahead and get y by itself. Well, it should be easily done for you guys. Move the 6 to the other side. And how do I get rid of the -5? Now, we are going to be graphing these here in a little bit, but I'm going to show you a really easy way to graph them. But for now, as long as we put the big fraction bar in, you could write it two different ways, and I will demonstrate both here. So I do have the y by itself. So we're allowed to write it with a giant fraction bar like so. Or you could choose to divvy them up and say, hey, I am dividing both portions by -5. Now, the only thing, you want to be a little careful here. So if I do split these guys up, then I have a -6 and a -5, which would make a positive 6/5. So if I were you, I would just leave the first version, one less thing to do. All right, now, I am going to hit you up for this if you don't do it. -1 symbol stands for inverse. Got to have it. Alrighty, so let's go ahead and try number 5 here. A little harder because of the fraction, but same concept. Hey, let's keep in mind that f of x means the same thing as y. In fact, if I were you, I might just go ahead and write y every time that I did these to start with. Okay, but let me switch up colors here. We did say that if you're going to write an inverse, you flip the x and the y. Because again, after all, the x and the y stands for an x-coordinate, and a y-coordinate. So I'm literally flipping the x and the y-coordinates. Well, how do I get y by itself? A couple different ways. I don't like fractions. I'm going to get rid of that fraction first. So I'm going to go everything times 3, which will get rid of this 3. Just don't forget that 8. Could have moved the 8 first. Either way would have worked. Now I'm going to move the 24. Notice my 2y and my 24 look awfully similar. And then I'm going to divide by 2. And again, you can do it either way. I'll just do it this way for no particular reason. Write it over here. So y inverse equals, don't forget the negative 1. So I've got a 3/2 x. And I do need to reduce always fractions. So 24 over 2. I'm not going to leave 24 over 2. I'm going to make it a 12. There we go. So there's our inverse equation for that guy. And back over here, inverse equation for that guy. Okay, now in the interest of time here, I'm going to skip down to the bottom and I'm going to graph these two, and then we'll come back and do the other two with part 2 video. So to give you an idea how to do some graphs. So number 4, original problem is y equals 6 minus 5x. Y equals 6 minus 5x. Now, I trust that we all remember how to graph simple linear equations. 2, 3, 4, 5, 6, a y-intercept of 6. My slope is 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And let me get the line feature here. It'll be fancy. Okay, close enough. Put some official arrows on the end of that. Okay, now you could use the equation that we did. Let me go back up here a minute. So this guy right here, that's going to be the inverse equation, the graph. But as you can see, it's got a fraction. Hey, how am I going to graph a y-intercept for that guy? So I'm going to come down here. I'm going to do this instead. And I'm going to say, hey, what are the coordinates that we just graphed? Well, this dot right here, and again, pardon me for missing on the line, was actually 0, 6. The guy right about here, when I moved down, counted my slope, that guy's 1, 1. And this guy down here, well, he's 2, negative 4. Well, go back to the very first problem we did. What did we do? We flip-flopped the x's and the y's. So if you want an inverse equation, the easiest way to graph it is just to literally flip the x's and the y's. So I'm going to go with 6, 0 instead. 1, 2, 3, 4, 5, 6. Coincidentally, if I flip the 1 and the 1, it would be the same. So that's still that guy. And if I flip my my 2, negative 4, sorry, it'd be negative 4, 2. So negative 4, 1, 2, 3, 4, 2. And I'll go ahead and connect those guys. As I find the line. And I guess we'll go with, there we go. And got it. Okay, now the last thing I'm going to point out 2 things to you. Number 1, this is the line of symmetry for an inverse graph, always. So every time you get done graphing these 2 graphs, they better be symmetrical over that line. So imagine those 2 guys flipped over that dashed line. They would land right on top of one another. And the last detail we're going to get into, and I see I'm running low on time, so for the other 3 graphs, you're going to have to stay tuned for part 2 video, is labeling. Anytime you label or anytime you draw more than one graph on a grid, it's just standard that you label them. So anywhere along the line is good. Some teachers will make you write out the entire equation. I'm just going to say, hey, if the original equation that we did was y, then somewhere right along that first initial line, we should put a y. And then the inverse one we just did here in blue, again, the notation for that would be y negative 1. So you do need to label those, and if you don't, well, I'm going to call you on it. All right, guys, you need to see some more graphs, and there is a different kind of problem in the second video, which is how to prove things are inverses of one another. So stay tuned for that, and thanks for watching.